As animators, it is important to understand how this momentum affects what we want to represent in motion, so that we may more accurately represent and communicate to our audience. Thus, understanding momentum and the law of conservation of momentum gives us another tool under our belt in our ability to animate, and thus makes us better animators. Here, you see two balls rolled towards each other. If you watch closely, the velocity of the balls is the same before and after the impact. Neither their mass nor velocity change, so neither does their momentum. Not all objects need to have momentum in the system for the law to work. As you can see, the first ball transferred its momentum to the second ball, and thus the momentum is conserved. Nor need there only be two objects. So long as each object in the system is affected, the momentum of each part added together is again the same before and after impact. The mass of the object does not need to be the same either. As momentum is mass times velocity, if an object of small mass and high velocity collides with an object of higher mass, then that second object will have a lower velocity, since the combined momentum is the same before and after impact. Here, Kona is now a part of the system because she is physically connected to the ball by sitting on it. The tennis ball is only able to transfer minute amounts of momentum, and thus retains most of it. Even so, the combined momentum of both parts is still the same before and after impact, so the law of conservation of momentum still holds true. Another important aspect of momentum is the law of conservation of momentum. This law states, in an isolated system, the sum of the momentum of each object within that system is the same before and after any impact. As Kona spins, you'll see that her tail continues to spin after her feet have landed on the floor. This is because there is still momentum in the tail, and without an external force to bring it to a sudden stop, it continues to travel. This is also apparent in the motion of these scarves. Though the hands change direction while in motion, the scarves do not immediately change direction with them, and instead continue in the original direction they were traveling. That's because the momentum of the scarf continues until there's enough force acting on it to change direction. Here, the balls are able to rotate continuously because the momentum is strong enough to act against the force of gravity, and is thus able to complete the full 360-degree circle.